Hi everybody and welcome. Today we're going to be talking about proving that triangles are congruent. So your goal after watching this video will be able to correctly identify and apply congruence theorems to proofs. So we're going to start off with a couple of examples of some things and properties that we know for sure make triangles congruent. We're going to go over an example of a proof, and at the end of this video it's going to be your job to write out two proofs of your own based off of these properties that we learned today. So you'll have an example of how to model your two proofs. So we're going to do one proof together, and you're going to want to use that proof to make two proofs of your own that are in the notes. So to start off, our first theory of congruence, angle, side, angle. This means that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. And we can use this in proofs. So if in a proof, if you prove that you have two angles and one side that are the same, then you can say that the triangles are congruent. So again, justification of a proof. We call this ASA, angle, side, angle. In that order, right? Angle, then side, then angle. We could do the same thing here for angle, angle, side congruence. So if two angles and a non-included side of one triangle are included to the corresponding two angles in a side of a second triangle, then the two triangles are congruent. So this is called angle, angle, side. So again, the order does matter. We go from angle to angle, and then next to side. The side is not between the two A's. Okay, so the A's go together, then the side is there. So angle, angle, side is how we call this one. So let's practice now using one of those two theorems to write ourselves a proof. So again, remember for proofs, we have our two-column chart of our statements and then our reasons. And here we're going to start off with what we are given. So first, we know that angle 1 is congruent to angle 2. And again, that is our given reason. See that right here. And then next, we know that AB bisects CAD. That's also given. So let's just take a look and see what that means here. So we have AB bisecting angle CAD. So what that means here is that our angle here and angle here, because they are bisected, again, remember definition of bisector, that means that they are congruent. So angle 1, which is angle CAB, is congruent to the measure of angle 2, BAD. And again, we can say this from the definition of bisector. Okay, so let's take a look at what we have so far. We know that two angles are the same. So first of all, we know, and let's just circle this, we know that this angle right here and this angle right here are the same. We also know, we just proved this, that this blue angle and this blue angle are the same. So we have two angles that are the same. Now we need to have a side that's the same. And if we look, they share a side. So on both triangles here, we know that in brown, that side is the same. So actually, we need to write this out. We need to prove it. We know that AB is congruent to AB. So again, on each triangle, the AB side of each triangle is the same. And again, this here, we're like, why would we ever need to use AB equals AB? Well, here's why. We need to write down in our proof that one of those sides for each triangle works, that it's the same. So here is our reflexive property, used for the first time probably for many of us. So again, AB equals AB, that's reflexive. So let's recap what we have. We have two angles and one side that are the same. So we're ready. Our reason is angle, side, angle. And we can now say that the triangles are the same because they have two angles and a side that are the same. So that's an example of how we would write out a proof. So your goal when you're trying to prove that triangles are congruent, your goal is to identify that, like, for example, two angles and a side are the same. And if you can do that, and you do it in the right order, so an angle, then a side, then an angle, then you have proven that the triangles are congruent. So that's the idea of proofs. Again, get the information that you need. Once you have it, put it into your proof, prove all the statements that you need, and then you'll finish your proof. All right, so 2 more tools that we can use in proofs. So if you don't have any angles, there's no way to prove any angles, we can still prove the triangles are the same if all 3 of their sides are the same. So this one here, if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. In a proof, we would call this SSS, or side, side, side. So if all 3 sides are the same, we know that everything else about these triangles is the same. There's no other way to fit them together if you have 3 side lengths that are the same. And then another thing we can use in proofs here, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. You can probably guess here, this is SAS, or side, angle, side. So these ones really emphasize the sides over the angles. So again, 2 more properties that we can use to justify that triangles are congruent in proofs. And our goal for 4.4, so of this video, is really to prove that these triangles are the same. And by saying prove, that means yes, in a proof. We are trying to prove in a proof that triangles are the same. All right, everybody, so as always, thanks for tuning in. Appreciate it. I will see you all in class.